Hello students, so today we are going to start new unit hydrogen and along with the regular textbook syllabus we will discuss about the competitive portion of this unit as well. So first let's start with the position of hydrogen in periodic table. So if you check the periodic table then you will see two different type of positions will be mentioned for hydrogen. In some of the cases, let's say this is our periodic table and as we know we have S, P, D and F blocks in this. So in some cases you may see hydrogen is mentioned here, and in some cases as we can see in the textbook, position of hydrogen is mentioned floating above the D blocks something here. So why these two different type of positions are mentioned in different type of periodic tables? So reason is, if we check the electronic configuration of hydrogen, then it is 1s1. That means it contains only one electron, and we know that periodic table is based on electronic arrangement. So if we observe the electronic configuration, then hydrogen resembles with alkali metal. That means first group elements. As for example, if we check the remaining elements or other elements of first group, as for example lithium, then electronic configuration of lithium is 1s2 2s1. That means just like hydrogen, it has 1s1, lithium has 2s1. Next element sodium, it will have 3s1, then 4s1 and so on. So on the basis of electronic configuration, hydrogen is like alkali metals. But if we check the behavior of hydrogen, that means chemical or physical reactivities, then it resembles or it is comparatively closer to halogens. That means on the secondary, we can think about this way. If we observe the electronic configuration of fluorine, then it is one electron short from the noble gas electronic configuration. We have 9 electrons in fluorine. That means it has 1s2, 2s2, 2p, 5 electronic configuration. Only one electron less than neon, which has 10 electrons. So similarly, if we check the hydrogen, then it has 1s1 electronic configuration, only one electron short from being helium like electronic configuration, because helium has 1s2 electronic configuration. So hydrogen resembles with both of them, alkali metals and halogens, in case of electronic configurations. But if we check the properties, or let's be specific, ionization enthalpy, that means delta Hi, or ionization enthalpy, that means removal of electron. When we remove electron from the atom, it is called ionization reaction. So ionization enthalpy of lithium and fluorine, they have comparatively large variation or deviation because they are very opposite nature from each other. Lithium is strongly metallic, whereas fluorine is strongly non-metallic, or it is very electronegative element. So normally electronegative elements have stronger attraction towards the electron, and that's why removal of electron becomes harder. Whereas metals have comparatively weak electron towards the electron, and that's why electron removal is easy in metal. So lithium has comparatively very low ionization enthalpy, which is 520 kilojoules. Fluorine has very high ionization enthalpy, which is 1680 kilojoules. And if we check about the hydrogen, then it is in between these two. It has 1312 kilojoules. So as we can see, on the basis of ionization enthalpy, it is very close to lithium, because as we can see, difference of ionization enthalpy between hydrogen and fluorine is around 370, whereas if we check it between the hydrogen and lithium, then it is nearly 800 kilojoules. So hydrogen is comparatively closer to fluorine in behavior, and that's why we see hydrogen floating between the elements. And you can verify it by observing a periodic table mentioned in textbook. Now if we check the hydrogen atom, then it has only one proton at the center and one electron revolving around it. All the other elements mentioned in periodic table at least have equal number of protons and neutrons. So in this case, we do not have any neutrons. So only one proton is present at the center and one electron is revolving around it. Now we already discussed about the size of atom and mass of atom in structure of atom unit. All of the mass of atom is because of nucleus. In nucleus we have protons and neutrons, and they are very heavier particles than the electron. Contribution of electron in mass of the atom is negligible. On the other side, if we talk about the size of the atom, then it is because of electron revolving around the nucleus. Contribution of nucleus in size is very negligible. With the practical example, if we compare the nucleus and size of atom, then let's say if the size of nucleus is about the size of tennis ball, then size of atom will be comparatively very large. It will be like a small city. Radius will be around 5 kilometers. Okay, we are talking about the size of tennis ball and 5 kilometer radius or 10 kilometer diameter. So that means if size of nucleus is like a tennis ball, then size of atom will be like a small city. So size is because of electron and mass is because of neutrons and protons at the center. So if we remove only electron of hydrogen, then only left is, or only remaining thing is a single proton. And that's why it has very small size. So if you convert hydrogen into H plus, then size of H plus, that means size of proton, single proton is around 1.5 into 10 raised to minus 3 pm, which is extremely small if we compare it with other ions, which are usually in between 50 to 200 pm. So comparatively, size of other ions are very large than the size of ion of hydrogen, and that's why ion of hydrogen do not exist in free state. If we produce H plus from the hydrogen, then it will combine with any element present around it. Now let's talk about the isotopes of hydrogen. We have total 3 different isotopes. Now if you don't remember what is isotopes, then isotopes are elements which has equal number of protons and different number of neutrons. So we have 3 different isotopes for hydrogen. They are known as protium, deuterium and tritium. So in case of protium, we have 1 electron and 1 proton but 0 neutrons. In case of deuterium, we have 1 electron, 1 proton and 1 neutron. And in case of tritium, we have 1 electron, 1 proton and 2 neutron. Now all the hydrogen we have around us, majority of it is in form of protium. We have some quantity of deuterium, and tritium is rarest of all of these 3. And tritium is also radioactive, so it is hard to study. We have very less quantity and it is radioactive, so we do not have much data available about the tritium. So tritium is radioactive, and that's why it releases beta particles. Beta particles are energized electrons, so it releases electrons in form of beta particle. Now all the radioactive elements releases some kind of particles, and they are differently known as alpha, beta, gamma, etc. So these alpha, beta and gamma are mainly either electrons or protons or neutrons or bunch of some. That means in some quantity radioactive particles will shoot out the electrons, protons or neutrons, and that's why when this electron, proton or neutron or bunch of them collide with other atoms, they make them unstable. And their details are mentioned in the table in the textbook. You can see it. If you have any confusion, then you can ask me. Now let's talk about the preparation of dihydrogen, and in this case we will discuss about 2 different type of reactions, laboratory preparation and industrial preparation. Now why we discuss 2 different type of reactions? Now first thing, laboratory reactions are comparatively easy and they will produce comparatively less amount of product, or they will be comparatively costlier, but they are safe. On the other hand, in industry our target is to produce maximum amount of product with the minimum cost and minimum time. So reactions may be dangerous. So industrial reactions are maybe dangerous, but they give large amount of products in comparatively less time, whereas laboratory preparations are comparatively safer with lower amount of products and it may take comparatively more time. We have two different type of laboratory preparation, and one of them is already discussed in standard 8 in unit preparation of gases. In that unit we have similar method. When we add hydrochloric acid on the nail or iron, then it will produce hydrogen gas. So similar type of reaction is mentioned here with zinc. Zinc is more reactive than the iron, then that means it can release more amount of hydrogen. So simply metals, they are more metallic than the hydrogen, and that's why they simply replaces hydrogen from the HCl. So zinc metal with HCl produces zinc chloride and hydrogen gas. Now second reaction is similar type of reaction. When zinc react with alkali or base, it produces a complex compound as mentioned here, sodium zincate, and it produces hydrogen gas. Now the second type of reactions are commercial production of dihydrogen. Now first reaction is electrolysis of water. Now if we have pure water, then it will be non-conductor of electricity, and to increase the conductivity of pure water or distilled water, we will add some minor quantity of acid or base. So that's why acidified or basified water, when we pass electricity from it, it produces hydrogen and oxygen gases. Now we already know that from the previous unit, oxidation state of hydrogen is +1 and oxygen it is in -2 oxidation state. When they produces H2 and O2, their oxidation states are 0, 0. So hydrogen is gaining electron, that means +1 to 0 oxidation state, that means it follows reduction, and oxygen has -2 oxidation state, and finally it gives 0 oxidation state, that means oxidation reaction, oxidation state increases or electrons are released. So because of this, H plus to H2 reaction will occur on cathode, because cathode gives reduction reaction, and that means on cathode you will see hydrogen gas bubbling, and anode gives oxidation reaction, so on anode you will see bubbles of oxygen. So that's how we can produce hydrogen gas. Now second reaction is the same type, but instead of water we will use barium hydroxide. So barium hydroxide is comparatively costlier than water, and it is obvious thing, water is freely available and we need to distill it, and it is comparatively easy reaction. And on the other hand, barium hydroxide is a chemical, and usually it will cost more than distilled water. So that's why this reaction is costlier, but if we want comparatively high purity hydrogen, as mentioned here 99.95% dihydrogen, then we have to use barium hydroxide instead of water, and it will give us hydrogen gas. Now the third reaction is, it can be obtained as a byproduct when we produce chlorine and NaOH or sodium hydroxide from brine or seawater. Now this reaction is also will be discussed in the standard 12 electrochemistry unit, and it is also our today's competitive portion. So let's discuss this reaction in detail. So brine is a seawater, that means it is basically solution of NaCl. So in solution of NaCl we have NaCl plus H2O. So as we know, NaCl produces Na plus and Cl minus, and H2O can produce H plus and OH minus. So we have four different ions competing with each other. And why they have competition? Because we are electrolyzing the solution, that means one of the electrode will give us reduction. So we have two different possibilities for the reduction, Na plus and H plus. Both of them will try to reduce itself. Na plus, if it participates in reduction, then it can produce sodium metal. If hydrogen can participate in reduction, then it can produce H2 gas. So we have two different possibilities and both of them will compete with each other. Similarly, on the oxidation stage or on the anode, we have two different ions, Cl minus and OH minus. Cl minus with the help of oxidation will try to produce Cl2 gas, and OH minus with the help of oxidation will try to produce O2 gas. So we have two competition on anode, two competition on cathode, either Na or H2 on cathode or Cl2 and O2 on anode. Now in previous unit redox reaction we discussed last topic or last table number 8.8 8.1, which mentions or which gives us the details or data about electrode potential, standard electrode potential. So these are the reactions, and on the last or far more right hand side we have reduction potentials or also known as cell potentials. So these are the values which indicates which element has more tendency to reduce. That means for the reduction of fluorine, as we can see value is 2.87, and for gold as we can see value is 1.4. So it means fluorine has more tendency to reduce than the gold. So similarly we can compare our elements mentioned in brine water. So we have hydrogen and sodium, both of them are trying to participate in reduction reaction. We know that hydrogen is being used as a standard and value of hydrogen is 0, and value of sodium as mentioned in this table it is minus 2.71. So it simply means we have more value for hydrogen. So it simply says hydrogen has more tendency to participate in reduction reaction than the sodium, and that's why on cathode hydrogen will participate in reduction, and that's why H plus will convert in H2. On the other hand, Na plus is not able to accept electrons because electrons will be accepted by hydrogen, and that's why no sodium metal will be produced and sodium will remain in Na plus form. And if we discuss about the production of oxygen and chlorine, then we have two possibilities here as well. But in this table all the reactions are mentioned for reduction, so we have to see in reverse. For chlorine we have Cl minus as initial reactant and it will convert into Cl2 gas. So Cl minus to Cl2, we have to see opposite reaction. So when chlorine gas produces Cl minus ions, its potential is 1.36. So reverse reaction will have opposite potential. That means when Cl minus produces Cl2 gas, potential will be minus 1.36. Similarly, from the water, when we try to produce oxygen, that means H2O to O2, its value is 1.23. So opposite reaction, that means it will be negative value minus 1.23. Now anode is exactly opposite of cathode. On cathode, higher value has more tendency to participate. On anode, lower value has more tendency to participate in reaction. So from this data, we can see chlorine has more tendency to participate because its value is lower and lower value is more preferred on anode. So that means in our reaction on cathode, sodium is not able to participate, so no product from sodium. And in reduction, hydrogen will participate and it will produce H2 gas. On anode, Cl minus will participate in reaction and it will produce Cl2 gas, and OH minus can participate in reaction. So that means on the cathode, you will see bubbles of hydrogen produced. On the anode, you will see bubbles of chlorine gas being produced. So H plus will be consumed and Cl minus will be consumed from the solution. And inside the solution, Na plus and OH minus will remain. That means Na plus OH minus together produces NaOH. That means sodium hydroxide. So in this reaction, our main products are sodium hydroxide and chlorine gas, and as a byproduct, hydrogen is also produced. Now next production method is Steam and hydrocarbon in presence of catalyst produces hydrogen gas. So when we have hydrocarbon with water or water vapor at high temperature with catalyst like nickel, it produces mixture of carbon monoxide and hydrogen gas. Now it is known as water gas, and this water gas is used for synthesis of other compounds, and that's why it is also called syngas. Now let's talk about the chemical properties of hydrogen. Hydrogen has single bond. That means in dihydrogen we have hydrogen single bond hydrogen. So two different hydrogens shares a single bonds only. But if we compare these single bonds with any other compounds present, then energy requirement to break this single bond is highest than the any other elements or compounds. So that means bond dissociation of hydrogen requires comparatively high amount of energy, and it is highest for single bond. So that's why hydrogen is comparatively inert. So normally it won't react at room temperature, and same thing can be observed if we heat the hydrogen gas with 2000 Kelvin temperature, then it dissociates in very less amount, less than 1%. But if you increase the temperature up to 5000 Kelvin, then this ratio will increase, or dissociation of hydrogen gas drastically increase up to 95%, more than 95%. Now hydrogen gas with a halogen gives usual reaction. Hydrogen is electropositive than halogen, so it releases electron and halogens accepts electron, and it forms hydrogen halide. That means H2 plus X2 produces HX, where HX represents hydrogen halide and X are halogen atoms. Now reaction with dihydrogen, so it is obvious reaction. H2 is flammable gas and O2 is combustion supporter. That means one of the reactant is flammable and second one is supports flame or combustion. So that's why they will release high amount of energy, and product will be water. So this reaction releases extreme amount of energy, and that's why this reaction is also used in rocket fuels. So rocket requires extreme amount of energy to lift up, and that's why H2 and O2 comes in handy. So this reaction is also used in fuel cells. Fuel cells are cells or fuel used in rocket. With nitrogen, it produces ammonia, and this reaction is also known as Haber process for the production of ammonia. Simply, N2 and H2 won't react with each other in normal condition because both of them are inert. But at high temperature and high pressure in presence of catalyst, they will produce ammonia. Now usually most of the metals are more electropositive than hydrogen. So electropositive elements tend to release electrons and electronegative elements tend to accept electrons. So metal loses electrons and hydrogen will accept. And that's why negative ion of hydrogen is known as hydride. So with metal, hydrogen produces metal hydrides. And with less reactive metals, hydrogen is more electropositive. That's why they can replace the metal from the solution. That means we can use hydrogen for the reduction of metals as mentioned here. So in certain oxides, hydrogen can replace metal or reduce metal in its metallic state. Now with many organic compound in presence of catalyst, we can get hydrogenated products. So two examples are mentioned here. When we have vegetable oil and when we want vanaspati ghee or vegetable ghee, we can simply use nickel as a catalyst, and when this oil reacts with hydrogen, it produces vanaspati ghee. So simply double bonds will break and hydrogens will be attached. Second reaction gives more view on it. So hydroformylation of olefins yields aldehyde which further undergoes reduction to give alcohol. So simple reaction H2 plus CO with RCH, where R represents alkyl groups. RCH double bond CH2. So simply double bonds will break. So this double bond, if it breaks, it creates two vacancies, one at the first carbon, one at the second carbon. So hydrogen will split. One of the hydrogen atom will combine with this carbon, second hydrogen will combine with CO, and then whole CO will combine with second carbon's second vacancy, and you will get this product. And same thing can be repeated again when this compound, that means aldehyde, reacts with more hydrogen. It simply breaks carbon oxygen double bond, and both of them will get 1 hydrogen. So carbon gets 1 hydrogen, oxygen gets 1 hydrogen. That means you will get alcohol.